All right then, so here I have some question from some previous question paper. It's a chemistry question, types of reactions. Okay, now basically here what is happening is I have the information provided to us, and right here we have the questions from the question paper. But now my strategy is to do this. We are going to explain everything that we know about types of reactions based only on these types of reactions that are provided to us. You understand? So now before we can solve these questions, I want us to talk about everything. We are going to unpack everything that we understand or everything that we know about these three types of reactions that are provided to us. Okay, and afterwards then we'll solve the questions, because solving the questions after understanding these things, it will be much more easier in that case, meaning I will be giving you some basics based on types of reactions, but only on these types of reactions according to this question. Okay, now let us read the information provided to us and see what is basically happening here. Now they say to us the flow diagram below shows three organic reactions that involve the compound 2-bromobutane. Okay, meaning we have a flow diagram of three different types of reactions. We have reaction A, reaction B, as well as reaction C. Okay, now all of these reactions, they involve this type of a compound which is called 2-bromobutane. Here we have 2-bromobutane, here we have 2-bromobutane, and then here we have 2-bromobutane. But one thing that I can tell you, or I can assure you, is that all of these three reactions, they are different based on their types. Okay, they are different based on their types. We have learned multiple of types of reactions, but for now we're just only going to talk about these ones. Okay, now okay, sharp, fine. Now let us go through these reactions individually. Let's start with reaction number A. Okay, we're going to talk about everything that you know. We're unpacking everything now. Now with reaction A, you need to see that we have the reactant side and the product side. Okay, now on the reactant side, what is given for reaction A? We are given the alkane and compound Y, meaning we do not know the exact name or the IUPAC name of compound Y in this case, meaning we're gonna have to determine that compound Y ourselves. Okay, and then again, one of our reactant that is also provided is an alkane. Guys, remember, do not forget what is an alkane. Alkane simply means a homologous series. Okay, there are about many. We have many alkanes under that homologous series, which is called alkane. There are many different types of organic compounds, or we simply sometimes call them the hydrocarbons. Okay, so alkane, it's a homologous series of a certain group of organic compounds. Okay, so we don't know the exact alkane that will be reacting with compound Y to form these products. Now in this side of the reaction, we are given everything, meaning we are given the products. Now the products that are provided to us is 2-bromobutane and HBr. Okay, now for a fact that we are provided with the products, it will be much more easier for us to determine the reactants. But now how so? Because that's tricky for a lot of people. So now let us focus on the product side. Okay, now we have 2-bromobutane and HBr. Most definitely you need to determine the type of reaction presented here before we can talk about everything. Okay, but before we can talk about everything, now here's the thing, here's the deal. Now 2-bromobutane, okay, this is a molecule, this is an organic compound. I get it. This, it's most definitely an organic compound. And then again, here we also have an organic compound which is called an alkane, but now we need to determine the name of this alkane. Now look, check. You take your organic compound, right, and then you take the parent chain, or the stem chain. The stem chain in this case is called, it's butane. Okay, butane. You also include your suffix, it's butane. Now this butane, most definitely as an alkane, you need to think of it as butane. Again, here we have a haloalkane, and then here we have the alkane. Out of this haloalkane, what do we see? We see bromine and butane. Haloalkane is a combination of bromine and butane, because bromo means bromine, right? We see a combination of bromine and butane, meaning this butane in these haloalkanes comes from this an alkane, meaning that means butane plus compound Y, in this case it will form 2-bromobutane. butane, right? That's what we see so far, isn't it? Now, okay, sharp, fine. In this haloalkane, we saw that butane comes from an alkane, which is butane. Now, where does bromo comes from? Remember, I said to you bromo is bromine, meaning bromo is supposed to come from compound Y. Okay, meaning this bromo comes from compound Y, which is going to be just Br. And then again, let's talk about this product, okay? Remember, again, these are the products. And this product and this product, all of these products are a combination of our reactants. Hence why butane comes from an alkene and bromo comes from compound Y, because it's a product which is a combination of the reactants. Same applies here. In this reactant, there must be in this product, there must be combination of the reactants, meaning there must be a way whereby this Br comes from and this H comes from. Most definitely, H we most definitely know it will be coming from alkane, okay? And therefore this H will be coming from an alkane, and therefore this Br will be coming from compound Y, which will be Br. Now, this is a type of reaction that is represented to us for reaction number A. Now, what is the name of this type of reaction? This type of reaction, it is simply called what? So remember here we have Br, sorry. It is simply called what? It is simply called the substitution. The substitution, or you can just call it a bromination, okay, whereby we substituted what? We took hydrogen atom from butane, we swapped it with Br from Br2, and therefore the products now were managed to be formed, okay? Meaning from butane, we took hydrogen. Okay, we took hydrogen and then from Br2 we took Br and we placed it there. And then what happened? 2-bromobutane got formed, whereby this Br, it was inserted into butane, and then hydrogen, it was extracted from butane and inserted to that Br, and therefore then that will be our product. Can you see it? So this type of reaction, it is simply called the substitution. We substituted the what? The atoms in this case, okay? Now, another type of reaction that we are actually going to talk about is reaction number B, okay? Now, with reaction number B, we are given the reactants, meaning from the reactant sides, everything it is given, okay? Everything it is given. Oh, by the way, for reaction A to take place, what are the reaction conditions that we know for this reaction, for this type of reaction to take place? It's you need heat or the sunlight, or you can just simply say you need the UV rays, the ultraviolet rays, for this reaction to take place. That's a reaction condition for this reaction, okay? And then again, on top of that, you need to remember that when we test for hydrocarbons, whether the hydrocarbons are saturated or unsaturated, we use this type of chemical reaction whereby we add the bromine into an hydrocarbon, whether the hydrocarbon is, therefore the product will tell, okay? Maybe we needed heat or there was no application of heat. Remember, whereby there will be a discolorization of what? Of the reaction. If the reaction discolors immediately, you know what type of a product, you know what type of reaction is this. You know what type of hydrocarbon here that was used was. Or if the reaction do not discolor immediately, therefore again you'll know what type of hydrocarbon that was used there, whether it's saturated or unsaturated. We did that. Again, now let's go to reaction B. Reaction B, we have like I said, we have the reactants. The reactants are provided to us. We have 2-bromobutane and KOH, okay? And then we have compound X, KBr, and H2O as our products. Meaning from our products, there is something missing there. It's compound X, meaning compound X, it is not provided at all. Now, okay, sharp, fine. Because we are given everything on our reactants, it will be much more easier to determine everything on our product side, okay? Now here, this is what is happening. Let's have a look at this. Now let's talk about the reactants, KBr and H2O. Remember, I said your products, it's a combination of your reactants. Meaning when I take KBr, I'm supposed to understand where does K comes from and where does Br comes from. When I take H2O, H2O can be hydrogen ion as well as hydroxide ion. Now I need to understand where does hydrogen ion and hydroxide ion comes from our reactant side. Now, okay, sharp, fine. Let's talk about K and Br. Where does K comes from? We can see from our reactants, K comes from KOH. And where does Br comes from? We can see that from our reactant side, Br comes from bromobutane. Okay, meaning bromobutane, that's why we got our Br. And then H2O, where does OH comes from? It comes from KOH, meaning K and OH comes from here. You get my point? And then where does H comes from? H comes from 2-bromobutane. Now this is what is basically happening. Okay, I get here we have 2-bromobutane. Now let me show you what happened. We have butane, bromobutane. It's 1, 2, 3 and 4, and then because we have 2-bromobutane, let's use it as a major product. We can have a major product. We have Br, and therefore this one, H, H, and H, and it reacts with KOH to form compound Y, which we do not know the name of compound Y plus K and Br plus what? Plus H and OH, which is H2O, right? Okay, now sharp, fine. Now this is what is happening. Like I said, Br comes from this, meaning Br comes from 2-bromobutane, and H also comes from 2-bromobutane. Now this Br, it will react with what? It will react with K from KOH, and this H will react with OH to form water. Now that means here, out of this compound, we managed to eliminate Br and H, and therefore this eliminated Br and H, they did what? They reacted with this compound here, which is potassium hydroxide, and therefore we left with what? We left with compound X. Okay, we left with compound X, whereby these radicals, they are going to fall to form double bond here, and therefore now what is happening? Now compound X will now be called what? Will now be called butane 2-ene. Okay, it's organic compound from alkene homologous series. Okay, whereby double bond will be formed, meaning more what? After the folding of radicals, and therefore there will be a formation of double bond right there. Okay, and this type of reaction, it is called what? This type of reaction, it is called the elimination. Okay, or it is called the dehydrohalogenation, whereby we removed Br and hydrogen. That's why, hence why, dehydrohalogenation. And therefore now this is what is happening. Again, it's very important for you to know the what? It's very important for you to know the reaction conditions that are needed for this reaction. Now for this reaction, it's either this type of, you use strong base all the time. Okay, for this type of reaction, which is called dehydrohalogenation, it's either this type of a base, it's called potassium hydroxide, like this one that you see, or you use lithium hydroxide, or you use sodium hydroxide. You can use one of these three strong bases so that this reaction can take place, whereby haloalkane, it becomes converted into an alkene for double bond. Okay, and again, the reaction conditions that are needed for this reaction to take place is what? Meaning you need a very strong concentrated base. Okay, this is a base that you need. It's supposed to be strong, and it's supposed to be very, very concentrated. Okay, and that will be reaction number B. Last but not least, I want us to talk about the reaction number C. Okay, with reaction number C, we have the reactants. Again, we have the product side. Everything, it is given to us on the reactant. And again, what is fascinating about reaction C is it is almost similar to reaction number B, whereby the reactants are the same. You need to take care of that. Okay, you need to be careful when it comes to these types of reactions. It only depends on your products. Okay, it only depends on your products, or if maybe you are given the reaction conditions. Therefore, you understand how reaction B and reaction C are different from one another, even though the reactants are the same. Okay, only if the reaction conditions are different, therefore you'll understand there is a differences between these two types of reactions, which is B and C. Now let's talk about reaction C now. Reaction C, this is what is happening. We have formed alcohol and KBr. Again, there is something missing here, which is an alcohol. Our alcohol in this case, it is not known, because an alcohol, it's a homologous series name. Okay, so alcohol, there are many alcohols that we can talk about, but for the fact that we don't know the exact alcohol that was formed out of these chemical reactions, we're gonna have to determine that for ourselves. Okay, but now before we do that, let us talk about this. Now here we have KBr. Okay, remember, it's a product, and this product, it was formed from these two reactants. Now you need to ask yourself this simple question: where does K comes from? It comes from KOH. Where does Br comes from? It comes from 2-bromobutane. Bromo, because there is a Br there is bromine. Okay. Oh, okay, sharp, fine. Let us draw the structural formula for this one. We have C, and then Br2Br here. We have H here. We have H. We have H. We have H. And there, and therefore we have plus KOH to form what? To form an alcohol, and KBr, right? K from this, Br from there. Okay. Now look, for the fact that our reactant, it was KOH. Now our reactant as a product turned to KBr. That means this Br took a place of OH, and OH took a place of Br, meaning that's a substitution. Okay, so that means, because where is OH, that means OH got substituted with Br immediately when there was a removal of this Br, and therefore Br reacted with K to form KBr, which is our product. And therefore what happened with OH? OH was just floating and decided to do what? To plug where Br was at, meaning this type of reaction is a substitution reaction. Okay, so now here we managed to form an alcohol, because immediately when this OH joins whereby Br was placed, it's going to be COH, meaning it's going to be an alcohol organic compound. And this type of alcohol, it will be formed during this type of reaction. And then again, what is the name of this type of reaction? This type of reaction, you can see yourself, it's a substitution reaction. Okay, it's a substitution reaction whereby we substituted Br with OH. Now, like I said, these two types of reactions, they are different from one another. But now, how do we see that? By the products formed. Okay, and number two, how do we see that? By the reaction conditions. Remember, we said for reaction B, we need a strong concentrated a base, but here in reaction C, we need a strong diluted base and mild heat for this reaction to take place. For reaction number B, we just need only strong concentrated base. Here we need diluted, strong base and mild heat, so that this type of reaction can take place. Now let us be quick to answer these questions, because we talked about everything. Okay, now write down the type of reaction for reaction number A. Now the type for reaction number A is gonna be what? It's very simple. Reaction number A, we said it's what type of reaction? Do you still remember? I'm giving you some few minutes to think over it. Pause the video and try to answer this question, okay, on yourself, because we talked about everything. Okay, so now for reaction number A, a type of reaction number A, it will be what? Yes, you are correct, meaning it will be, yes, it will be substitution. Or you can just simply say it will be a bromination. Okay, it will be substitution or a bromination reaction. Now let us move to 1.2 for reaction number B. Write down the type of reaction number B. Reaction number B, we said a reaction number B is what type of reaction? Yes, it is elimination. Okay, it is elimination. And therefore for number 2, for reaction A, write down the name or formula of the inorganic reagent Y. We need the inorganic reagent Y. What is the name of inorganic reagent Y? Remember, what compound did we use here? And it is inorganic. We know why, okay, because we have already learned what are the organic compounds. So this is just Br2. Doesn't have carbon, doesn't have hydrogen atoms, meaning it will be Br2. Okay, just write the name, or you can say bromine, or you can just write Br2. It will be Br2. Okay, now for reaction A, write down one reaction condition needed for the reaction to take place. They just need only one. Remember, we talked about two for this reaction, which is reaction A, okay, whereby there was a substitution reaction, bromination reaction. So now, remember this type of reaction, like I said, we use this type of reaction to test what? To test for saturation and unsaturation of organic compounds. Now, one reaction condition needed for reaction to take place is heat or sunlight. Okay, you can just say heat. You need heat. Another type of another reaction condition that is needed for that reaction to take place is, or you can just say you need UV light. Okay, you need UV light, or you can just say UV rays. Okay, and in 2.3 they say give the IUPAC name, of the alkane. Okay, give the IUPAC name of the alkane for reaction number A. What is the IUPAC name for the? They need name, okay, not structural formula. Be careful, guys, when answering this type of questions. IUPAC name of the alkane, meaning the IUPAC name of this alkane, we said it's butane. Okay, we said it's butane. It's butane. Okay. Now number 3, they say write down the structural formula of compound X, the major organic product produced in reaction number B. Now this reaction number B, they want you to write down the structural formula. We need the structural formula of compound X, and we're going to write the structural formula as the major organic compound. Okay, so now how are you guys? I showed you these things when I was explaining there, okay, so it will be much more easier for you to do that. So for compound X, it will be what? Meaning it will be let me write here as a major product. Okay, remember this type of reaction, it's a what? It's a elimination, right? It's elimination. So we have butane, it's 1 2 3 4, and when we got rid of what? We got rid of PR and H, and therefore these radicals, they fall to form a double bond, and therefore now this will be a structure formula for compound X. Okay, properties of carbon, supposed to bond 4 times, 1 2 3 4. Here we have H, 1 2 3 4, then here we have H, we have H right there, meaning this will be a structural formula for what? For compound X. Okay, now question number 4, it says write down the structural formula of the alcohol produced in reaction C. The alcohol produced in reaction C, remember, again I showed you what will be the alcohol. Remember, this is butane, right? Now what did we do? We did a substitution. This type of reaction is a substitution whereby 2-bromobutane gave off bromine, and then KOH gave off what? A hydroxyl group. Okay, so now meaning we have something like this. It's gonna be butane for 4, 1 2 3 4, right? And therefore there will be COH here, and therefore here we have H, 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 and H, and therefore this will be the structural formula of an alcohol formed during this type of reaction, which is reaction number C. Okay, and that will be number 4. Now let's move on to number 5. They say write down 2 reaction conditions that will favor reaction C over reaction B. What will favor reaction C over B? Remember, I said they are almost the same, but there is something different about them. Now here are the 2 reaction conditions. Number 1, reaction C needs what? It needs strong diluted base. That's the first reaction condition. And reaction condition number 2 for reaction C to favor over B is what? We need heat, moderate or mild heat. You can just say mild heat or moderate heat, and therefore that will be how you answer these questions. Okay, so if you feel like you do not understand, feel free to pause, rewind all of those things so that you can understand it. And thank you for watching.